Good evening, sir. Good evening, madam. Actually, today I don't have proper connection. I don't know how to interact the Zoom app also. That's why I didn't attend that demo class at afternoon session. So really, I am very sorry to this one. Please excuse me and forgive me. Now myself, Sri Ramulu, I am working as a chemistry faculty in junior college, that means in Eklavya Junior College and IIT Foundation School section also at Nalgonda. Now, today I am going to explain about one important concept. Actually, in our chemistry, we know very well about the different type of chapters: physical, organic, and inorganic. But these total portion which are completely depends upon that three most important chapters. Those are atomic structure, periodic table, and next one is the chemical bonding, and next one is chemical bonding and molecular structure. So here I am choosing that chapter, one of the interesting chapter, now, that is chemical bonding and molecular structure. Now here our chapter name is chemical bonding, chemical bonding and molecular structure. So chemical bonding and molecular structure. Okay. So this is our chapter name. Chemical bonding and next is the molecular structure. Now our topic is MOT concept. So today I am ready to going to explain. Today I am going to explain about that MOT concept. And now it is very important concept in that chemical bonding theory. That means chemical bonding chapter. You know about the valency bond theory and hybridization phenomena, ionic bond formation, covalent bond formation, and next the Fazan's rule. Okay, next one is the Vesper and Lewis theory, Vesper quotient and Vesper theory. Now here our concept is the molecular orbital theory. Okay, our concept name is the molecular orbital theory. Now actually in molecular orbital theory should be depends upon that LCAO. Okay, now that means linear combination of atomic orbitals. Linear combination of atomic orbitals. Now that is linear. Okay, now that one is the combination of atomic orbitals. Linear combination of atomic orbitals. So in this case, the atomic orbitals which are approaching in that linear manner. Okay, the atomic orbitals are which are approaching in that linear manner. So that is the linear combination of atomic orbitals. Now here linear combination of atomic orbitals. So according to Lewis dot structure, we know about the oxygen molecule. Now here Lewis dot, okay, Lewis dot structure of O2 molecule. Lewis dot structure of O2 molecule. Now here we should draw the Lewis dot structure like this one. So this is the O2 molecule structure. O2 molecule structure. Now here according to Lewis dot structure, O2 molecule must be diamagnetic in nature. Okay, now that means it must be, okay, it must be diamagnetic. Okay, it must be diamagnetic property, but it's not shows that diamagnetic nature. Actually now it is the double bond character. Okay, two bonds are present in between the oxygen atom, so it must be exhibit that diamagnetic property, but it's not shows that such type of property. Actually here it is the paramagnetic in nature. Okay, and this one is the paramagnetic in nature. Okay, it was explained by that okay, this one is the explained by MOT concept. Okay, it was explained by that MOT concept. Okay students, so this is the important concept of that one. Now here according to the MOT theory, now we want to talk about the MOT concept. So first one, now here this one is the according to MOT concept. So in this concept we should describe about that now the three important properties, or maybe three important statements. Now the first one is the now it is the extension of that VBT theory. Okay, now first statement is the it is the extension. Okay, it is the extension of VBT theory. So that means actually here the molecular orbital theory should be used the support to extend of the term VBT theory, that is valency bond theory. And actually second property of this one is the now here atomic orbitals combined. Okay, now that means atomic orbitals combined to form, now those are the molecular orbitals. Okay, atomic orbitals are combined to form molecular orbitals. Now here we have to cover the one important concept also. Now the atomic orbitals are combined to form a molecular orbitals, means atomic orbitals are overlapping with each other. Okay, atomic orbitals are overlapping with each other, then they can form that molecular orbital. Okay friends, and now third statement is the electrons in an atom. Okay, electrons in an atom is attracted in the nuclei of atom. Okay, nuclei of that atom, or at the same time the electrons in the molecule which are attracted in the molecular nuclei. Okay students, now here that means electrons. Okay, now the electrons in an atom. Okay, electrons in an atom is in attraction, electrons in an atom is in attraction in, now that is atomic nuclei. At the same time second one is the electrons in molecule. Okay, electrons in molecule is in attraction of, now that one is the molecular orbital. Okay students, now that one is the molecular orbital. Actually this is the concept of that MOT theory. Okay students, now here I want to explain that, means I will explain about this concept with the help of diagrams. Okay students, now first one is the according to the molecular orbital, that means according to the MOT concept, it is the extension of the VBT theory, and the atomic orbitals are combined to form a molecular orbitals. And next one is the electrons in an atom is in attraction in the atomic nuclei, and electrons in a molecule is in attraction of molecular nuclei. Okay students, so this is the concept. Now first here I want to take that atomic orbitals okay, and combined to form a molecule. So I will give them molecules, that means I will explain about the concept with the help of molecular diagrams. Now this means actually, so this is the one atomic orbital. Okay students, one atomic orbital. Now here this is the central part of the atom, that is called as the nucleus. Now the electron is present at the outermost orbital. Okay students, now here also same, I will take that another atomic orbital. So this is the central part of the nucleus, the central part of the atom, it is called the nucleus, and here we have that electron. Okay students, now the electron of this atom is attracted by this nuclei. Okay, and here also same, the electron of this atom is attracted by this nuclei. Now the nucleus of the A atom, and it may be nucleus of the B atom, nucleus of the hydrogen atom, or it may be nucleus of the hydrogen atom. Okay students, now you can assume like this one is the hydrogen atom, and here are the same hydrogen atom. Okay, you can assume like this one. So now the electrons of this atom, the electron of this atom is attracted by this nuclei. Now here also same, the electron of this hydrogen atom which should be attracted by that nuclei. Now the both can combine together, they can form that this type of molecule. Okay students, now this one is the molecular orbital diagram. Okay, Now this one is the now it is the molecular orbital diagram. It may be okay. That means overlapping process. So this is the nuclei of that A atom, hydrogen atom, and here also same nuclei of that second atom. Now here the electrons which are mixing with each other. Okay, the electrons are comes to closer. The electrons are mixing with each other. Then what happens here? Now that means actually these electrons are attracted by this nucleus. At the same time, this electrons also attracted by the second nucleus. Okay, students. Now this one is the atomic orbital. Here also atomic orbital, but this one is the molecular orbital. Now the molecular orbital is okay. Now it is the molecular orbital is stable, and atomic orbitals in the atomic orbitals are the less stable. Okay. Now these are that means less stable in nature, or it may be now these are the unstable. Okay, students. Now these are that means more stable. Okay, and at the same time now these are having that more attraction. Okay, students, more attraction in between the two nuclei of atoms. Okay, in between the two nuclei of atoms. So this is the combination of that one. And next one here, now the second one is the next property of that one is the according to VBT theory. Okay, students. But this one is the according to molecular orbital theory. But the next one is the according to VBT theory. Now according to VBT theory, okay, students. So this one is the according to VBT theory. Here what happens here? So this is the one atomic orbital and combined with another atomic orbital. Okay, students. Another atomic orbitals. So these atomic orbitals combined to form a one molecular orbital. Okay, one molecular orbital. So according to the VBT, so this one is the atomic orbital. Okay, here this one is the atomic orbital, and here also atomic orbitals combined to form that molecular orbital. But according to this concept, now these are categorized into the two types of bonds. Okay, students. Now these bonds are categorized into the two types of. One is the sigma bond and next is the pi bond formation. Okay, now sigma bond and next is the pi bond formation. So sigma bond is the strong bond and pi bond is the weaker bond. Okay, but here what happens here in this statement? According to valency bond theory, two atomic orbitals are combined to form a one molecular orbital. Now here, how many atoms are combining with each other? How many atoms are participating in the bond formation? Two atoms are participating. How many molecular orbitals are produced, or how many molecular orbitals are generated in that combination? Only one molecular orbital. Okay. Now here in this combination, two atomic orbitals are participating in this one, but it should produce only one molecular orbital. But at the same time, according to the molecular orbital concept, okay, students, according to the molecular orbital theory, MOT concept. Now here number of, okay, students, molecular orbitals, okay, number of molecular orbitals are formed, which is equal to the number of atomic orbitals participated. Okay, number of, now this one is the atomic orbitals participated. Okay, friends, so this one is the number of atomic orbitals participated. So here that means number of molecular orbitals are formed. Okay, number of molecular orbitals are formed, which is equal to the number of atomic orbitals are participated, or number of atomic orbitals are involved in that bond formation or in that overlapping process. Okay, students. Now that means we should take the two atomic orbitals. It should provide that two molecular orbitals. Okay, students. Now if the two atomic orbitals are involved in that bond formation, two molecular orbitals should be provided or produced. So this is the concept, student. And next one is the here. Now in this case we should take that. So this one is the one atomic orbital, and here also this one is the another atomic orbital. Okay. Now it can form the two types of molecular orbital. Now here this one is the now the molecular orbital, and here also molecular orbital. But this molecular orbital is the now that is bonding molecular orbital, and this one is the anti-bonding, okay, anti-bonding molecular orbitals. Okay, anti-bonding molecular orbitals.
If you take the one example to illustrate about this one, okay students. Now here this one is the 1s orbital, okay. 1s orbital is combined with another 1s orbital. Now from this combination or by this combination we should get that this type of orbitals. Now here one is the sigma 1s2 and here will be the sigma star 1s2, okay students. So here that means actually here sigma 1s2 means bonding molecular orbital, and here is the sigma star 1s2 means now that is the anti-bonding molecular orbital, okay students. Now this one is the anti-bonding molecular orbitals. Now in this case two atomic orbitals are approaching with each other, at the same time it can produce the one molecular orbital, and this one is the one anti-bonding molecular orbitals are formed, okay students. Now this is the explanation about that one. And next one is the molecular orbital theory is depends upon that the following factors, okay students. Now here we have, now it is actually really very important concept to explain about that various factors, okay. Now first one is the fourth property of molecular orbital theory. Now here this one is the MOT is okay. MOT is depends on that, okay. Depends on that. So first one is the now the first and most important is now the MOT is depends upon the de Broglie's equation, okay. Now this one is the de Broglie, okay, de Broglie equation, or it will be de Broglie theory. So this one is the first concept. And the second one is it should be followed by that of Heisenberg's uncertainty principle, okay students. So this one is the Heisenberg's, okay, uncertainty principle, okay, Heisenberg's uncertainty principle. So this is the second one. And the third one is now what about the third one here? Schrodinger's wave equation, okay students. Now this one is okay, now that one is Schrodinger. So this one is Schrodinger wave equation, okay students. Now actually this is the fourth statement about that wave about that molecular orbital theory concept, okay. Now here it's not VBT, now it is the according to that molecular orbital concept. So according to the molecular orbital theory, we should be depends upon that now these factors here. So first one is the de Broglie's theory or maybe de Broglie concept. Now the next concept is the Heisenberg's uncertainty principle, okay. And last one is the Schrodinger's wave equation, okay students. Schrodinger's wave equation. Now the de Broglie theory means now actually this is the nucleus, that means this is the orbital of an atom. Now what is the nature of the particle here? Now that means the electrons are moving as a waves, okay. Now according to de Broglie scientist, okay. Now the waves which are moving as a, that means the electrons are moving as a waves like this one, okay. So it indicates that means it describes about that de Broglie's concept, okay students. And one more thing is the here you should take this one, okay. So this one is the amplitude, okay. Now actually it is the what about this one here? Now this is the amplitude. So it is denoted by the top this one. Now the probability of finding of electron is that means that information is given by the psi square. But in case of amplitude, psi has no complete meaning, okay. Psi has no complete meaning, but psi square has the complete meaning, okay students. Psi square has the complete meaning. So that means here psi square is the probability of, or it is the probability function, or it is the probability of finding of an electron, okay students. So this is the concept of that one. So these things are covered in that fourth statement, okay students. And the next one is the now here, and the energy of the anti-bonding molecular orbital theory is greater than that of bonding molecular orbital theory, okay students. Now the next concept about that now the energy of the anti-bonding molecular orbital theory, okay. Energy of the anti-bonding molecular orbitals is greater than that of bonding molecular orbitals, okay students. Now here once again this one is the, so this is the fifth statement. Now here that is the energy of anti-bonding, okay, anti-bonding molecular orbital is greater than that of now here this is the energy of, okay, bonding molecular orbital. Okay, bonding molecular orbital. Now that means now here the energy of the anti-bonding molecular orbitals. So these are having the greater energy and then the of energy of bonding molecular orbitals. Okay, students, bonding molecular orbitals. Now here we have the two important statements in this one. So it is also very interesting concept. Now that means the simple thing here you think about that one. Now for example, so this is the now the for example I will write that okay now formula. Now that is the sigma 1s is less than that of sigma star 1s. Okay students. Now here sigma is the bonding molecular orbital formula. That means it will describe about that bonding molecular orbital theory, bonding molecular orbital, and this one is the anti-bonding molecular orbitals. Okay, anti-bonding molecular orbitals. So here anti-bonding molecular orbitals are having greater energy than the top of bonding molecular orbitals. Okay students. Now here if the electrons are filled in that bonding molecular orbitals. Okay students. Now as the now that means as number of electrons are filled, number of electrons are filled in bonding molecular orbitals. Number of electrons are filled in the bonding molecular orbitals. It increases the stability of that molecule. Okay students. Now when the number of electrons are filled or the number of electrons are increased, okay, number of electrons are increased in the bonding molecular orbital, then now that means actually here the stability also, okay students, now the stability also increases. And next one is the as number of electrons, okay now as the number of electrons are increased, okay now as the number of electrons are increased in anti-bonding molecular orbital, then the time, okay now then the time the stability of that one is decreases. Okay now this is the important statements about that one. Okay students. Now in case of this one, now this is the energy of anti-bonding molecular orbitals, and this one is the energy of bonding molecular orbitals. So energy of anti-bonding molecular orbitals are having the greater energy, and the energy of bonding molecular orbitals are having the lesser energy or lower energy. Now here as the number of electrons increases in the bonding molecular orbital, the stability also increases. And next one is the as the number of electrons also increase in that anti-bonding molecular orbitals, then the stability of that then the stability should be decreased. Okay students. So this is the phenomenon. Now here one more concept is here. Now we want to cover that one. Now actually now that means if you take that now the anti-bonding, okay students. So this one is the anti-bonding. What about this one here? Bonding. Okay now this one is the bonding molecular orbital, and this one is the anti-bonding molecular orbital. So here sigma star is having, so that one is the high energy level, or it has the higher energy. Okay students. When it has the greater energy or higher energy, okay, now it is highly, okay students, highly, now that one is the unstable, highly unstable. Then what happens here? It has high energy or it has the higher energy, then it is a highly unstable. Now that means highly unstable. Now here this is the high, that means the sigma means it has the higher energy and highly unstable and low stability. Okay students, of course it is enough for that statement. Now the highly unstable means low stable, or it may be less stability. Okay students. So this is the concept of that anti-bonding molecular orbital theory. And next one is the filling of the electron. According to the molecular orbital theory, the filling of the electrons, it should followed by that three principles friends. Okay now one is the, one second here, wait. Now that means here filling according to MOT, okay, according to MOT, now that is the filling of okay now filling of electrons, filling of electrons in orbital, filling of electrons in orbital, it should follows, okay students, it should follows now three principles, okay. Filling of electrons in an orbital, it should follows three principles. So first one is the, you know about that one. What about the first principle here? Now that is above principle, okay students. So this one is the above principle. So second principle is that now actually first one is the according to MOT, filling of electrons in orbital is or it follows the following concepts. So first one is the above principle, and second one is the Hund's rule, okay students. Second one is the Hund's rule. And what about the third one here? Third one is now this is the Pauli's okay exclusion principle, okay students. Now this one is the Pauli's exclusion principles, okay. These are the three that means three statements. So you know about that one. First one is the above principle. Above principle means above principles about that the electrons are enter into them, okay. The electrons are enter in a orbital in the increasing order of their energy levels, okay students. Once again, according to above principle, the electrons are enter in a orbital in increasing order of their energy levels, okay students. For example, you should take them s orbital, p orbital, d orbital, f orbital. So this one is the s orbital is the lesser energy level, then p orbital which is also lesser energy level, then d orbital, and last one is the f orbital, okay students. And the second one is the now the Hund's rule. According to Hund's rule, now that means the pairing is not takes place, okay. The pairing of the pairing is not takes place until the each orbital having at least one electron, okay students. So that is the concept of the Hund's rule, okay. Once again here, the pairing is not takes place until each orbital containing at least one electron in that orbitals, okay. If it is not having the at least one electrons in that orbitals, it is not ready to, okay, now pairing it's not ready, takes the pairing of electrons. What about the last one here? Pauli's exclusion principle, okay students. Pauli's exclusion principle. So in the Pauli's exclusion principle means now here that means the maximum of the electrons in any orbital is 2. That means maximum number of the electrons in an orbital, that means in any orbital is 2. So these are the most important principles which are useful to describe, to explain about that MOT theory concept, okay students. Now this is the MOT theory concept, and here and next one is the now up to here we have completed the various types of, okay, molecules, okay, so various types of statements. Now we want to talk about the last one is the what about the last one here? Bond order concept, okay students. Bond order concept. Now how do you find out that bond order according to the MOT theory, okay students. Now the bond order, seventh one is the bond, okay students. Now this one is the bond order. So here bond order is equal to, okay, now 1/2 or half of the non-bonding electrons minus next one is the anti-bond, sorry. Now here bond order is equal to half of the number of bonding electrons minus number of anti-bonding electrons, okay students. Now here that means NV is equal to the number of, okay, that one is bonding electrons, number of bonding electrons, and Na is equal to number of anti-bonding, okay, electrons, okay. Na is equal to number of anti-bonding electrons, okay students. Now here if the bond order is equal to less than equal to 0, okay students. Now the bond order is less than equal to 0 means molecule, okay, the molecule does not exist, the molecule does not exist, okay students. So this is the one of the important condition. And second one is the now here bond order is greater than equal to 0 means molecule, okay students, molecule should be exist, molecule should be exist. And here the bond order is equal to 1, that means single bond formation, okay students. Single bond formation. Okay, a single bond formation. We should take the one example, that is the hydrogen and hydrogen. Okay, students. Now the bond R is equal to 2. Now that is the double bond formation is takes place. Now that means oxygen double bond oxygen. And here bond R is equal to 3 means now that is the triple bond formation. Okay, students, the triple bond formation. Now that is the nitrogen triple bond nitrogen. Okay, students, nitrogen triple bond nitrogen. Okay. Now once again here, now the last statement of this one is the bond order. Okay, bond order is equal to half of the number of bonding electrons minus number of anti-bonding electrons. Now here Nb is equal to number of bonding electrons, Na is equal to number of anti-bonding electrons. Now the bond are greater than less than equal to 0 means molecule does not existing. Okay, students. So if the less than equal to 0, okay, less than equal to 0, so the molecule does not existing. And here greater than equal to 0 means here students not greater than, here less than equal to 0 students here. So this one is the less than equal to 0. Okay, molecule does not exist. And here bond are greater than equal to 0 means now this the molecule should be existing, and bond R is equal to 1 means single bond formation. For example, hydrogen molecule. Okay, and next one is the bond R is equal to 2, that means double bond formation in between the oxygen. And bond R is equal to 3, that means a triple bond formation. Okay, now the triple bond takes place in between that. Okay, now that is nitrogen. Actually here bond order represents the, okay students, bond order represents the number of bonds present in a molecule. Okay students, bond order represents the number of bonds present in a molecule. Now we have the one statement, students. Now when the bond order increases, okay students, bond order increases, then the time, now that means bond strength also increases. Okay students, bond strength also increases. Bond order increase means bond strength increase. When the bond strength increases, that means bond length decreases. Okay students, so this is the property of that one. Okay, bond order increases, bond strength also increases. When the bond strength increases, bond length also increases. No, sorry, bond length decreasing. Now that means here bond order is inversely proportional to that of bond length. Okay students, bond order is inversely proportional to the bond length. If you take the now that is a triple bond, now the strength of the bonds, okay, triple bond has the greater strength than the top double bond, which has the greater strength the top, okay, single bond. And at the same time bond length order. Okay, now here check the camera, is it clear now? Bond length order. Now that means here single bond has the greater bond length, then double bond which has the greater bond length, and next one is the triple bond. Okay students, now here these are the very short bonds. Now here the medium, this one is the greater bond length. Okay students, now here bond length is very higher, and in this case bond length is very low. Now the strength of bonds, okay, that means now the triple bonds has the greater strength than the double bonds which are has the greater strength than the top single bond formation. Okay students, now up to here I have covered only the concept of that molecular orbital theory. Okay students, but here what are the conditions about that molecular orbital theory? That means which type of conditions are followed in that molecular orbital theory. Okay students, now first you listen. Now the first important concept is now that means the participating atoms, the participating atomic orbitals both must be or both possess same energy levels. Okay students, now actually overlapping is takes place. Okay, overlapping is takes place, or okay, now that means bond formation is takes place. The atomic orbitals should have, or the atomic orbitals should have same energy levels. Okay, now the conditions for that overlapping. Okay students, now first one, now here that is the conditions for that, okay, MOT theory. So that means which type of conditions are supported to that molecular orbital theory. Okay students, now the first condition is the combining atomic orbitals must have the same energy level. Okay, friends. Now here that one is the combining atomic orbitals. Combining atomic orbitals have same energy level. Okay, friends. Same energy. Now the combining orbitals have same energy. Okay, that means, for example, for our understanding purpose, I want to take that one molecule. Now we should take the 2s orbital is combining with another 2s orbital. So that means this type of combination is allowed. Okay, students. And at the same time, you should take the 2s orbital is overlapping with 2p orbitals. Now it is also, that means this type of combination also allowed. Okay, students. But if you take the 2s orbital is combining with 6p orbitals, that means it is not allowed that bond formation due to when the size of the orbital, that means when the difference of the size in the orbitals, when the difference in the size of the orbital increases, overlapping decreases. Once again, students, when the size difference increases in the orbitals, when size difference increase in the orbitals, okay, it is decreasing the overlapping phenomenon. And the second concept is the same symmetry of the orbitals. Okay, that means the combining orbitals must possess same symmetry or equal symmetry. Okay, that means the second condition is that now the combining orbitals may having that means may have same symmetry. So that means same symmetrical. Now that means along the axis. Same symmetrical along the axis. Okay, students. Now that means the second condition of the molecular orbital theorem. Now the molecular or the atomic orbitals are having same symmetrical along the axis. For example, students, so now I want to take that one type of combination. Okay, so this is the s orbital, like this is the p orbital, and again you should take the same type of p orbital. Okay, now this type of combination is allowed. Okay, this type of combination is allowed, and you should take that now here one s orbital is combined with another s orbital. Now it is also allowed. Okay, students, and one more thing is the now if you take that so this is the px orbital and the same like px orbital now gives rise to it is also allowed. Okay, students, so it is also permitted. But here now the proper symmetry, now these are combining with, these are overlapping with the same symmetry. Now these are also overlapping with the same symmetry. Now here also overlapping with that same symmetry. Okay, students, same symmetry. But here if you have to change the symmetry of the atomic orbitals, now it does not undergo to the overlapping process. Okay, students. For example, here you should take the s orbital is overlapping like x px orbital. So then it is not possible. Okay, students. So this type of orbital is not formed. Okay, and here you should take the so this one is the pz orbital overlapping with the px orbital. So it cannot form that hybridized orbital. Okay, students. So here. And last one is the now the means actually the third concept of the third condition. Now actually these atomic orbitals are having the interference in between the two waves. Okay, students. Now the atomic orbitals are combining with each other. Now in this case we have to use the one important physics concept. Now that is the interference of that atomic orbitals. Interference of the atomic orbitals. When the interference of the atomic orbital, when the interference of two atomic orbitals can forms that constructive interference of the compounds, and next one the destructive interference of that molecule. Okay, students. Now in this combination, now we have the first one is the interference of atomic orbitals. So that is the molecular orbitals. Now that is actually interference. So this one is the interference of atomic. Okay, students. Atomic orbitals. They have interfering with in between the two atomic orbitals. They can form that two types of combination. Now one is the constructive interference. Okay, students. So this one is the constructive Now that is interference, constructive interference. Now here this one is the destructive interference, students. Okay now. So this one is the destructive interference. Okay, this destructive interference. Now here what happens in case of constructive interference, amplitudes are combined in the same phase, then they develop that amplitude, the length of the amplitude should be developed. But in case of destructive interference means now the two atomic orbitals combining in the opposite phase, that means sign. Okay, opposite phase or maybe sign, so they can form that destructive interference. Okay students, so for this combination I want to write here, so this is the one wave. Okay students, one wave. So this one is the amplitude. Now here is the negative sign, this one is the positive sign. And again now here it's not charges, now simply sign. Okay, it's not charges. So actually here in this setting or video, now the time is not sufficient to complete that interference of these molecules. Actually it can form the constructive interference, that means it is developed that okay now phase development, that means the same amplitude development. But in the second case destructive interference means now that means they are cancelled with each other. Okay students, that they have to cancel with each other. So in this case it increase them like this one, but in this case actually now this can decrease that okay interference of that one. So thank you one and all.